Assalamualaikum and good day to everyone. So welcome back. Let's proceed our discussions on enrichment 1A. So the question is, two insulated metal plumber and copper with thickness of 40 mm and 60 mm respectively are joining together. So dekat dalam gambar ni I dah lukis. So sebelah kiri kita ada plumber and on your right hand side is your copper with different thickness for 40 mm for the plumber and 60 millimeter for the copper. So I dah label as you can see from your screen right now. So the thickness for the plumber is 40 times 10 power of negative 3 meter. I convert into SI unit, and the thickness for the copper is 60 times 10 power of negative 3 millimeter. And then it said that the temperature of the plumber is fixed at 70 degree Celsius. So kat sini I label siap-siap on your left hand side, which is the temperature for the plumber, which is 70 degrees Celsius, and then the copper temperature is 30 degrees Celsius. So I did label those temperatures already. So if the thermal conductivity of the copper is 4 times of the thermal conductivity of the plumber, so you have to take out the important info from the sentence. So it said that thermal conductivity of the copper, so K for copper is actually 4 times K of the plumber. So yang ni you kena take out from the sentence. Okay, the important info. So the question asks for calculating the boundary temperature. So means the boundary temperature is the junction's temperature. So temperature between the boundary PB and copper. So dekat sini lah actually. So T2 lah. Okay, I label the boundary temperature as the T2. So when the question said that steady state, you have to know that the rate of the heat transfer for both metal, plumber and copper are the same. So yang ni you kena tahulah. So ini the important things that you have to write down. Okay. After you do that, so kita masukkan equation dq per dt, which is, so the left hand side is belongs to plumber, so kita akan masukkan K plumber, and then area, what happened to the area, it said that assume the cross-sectional area are the same. So area kita sama, so we just label as A lah. Okay, and then the difference in temperature should be T final, you minus dengan T initial. Okay, and then you divide with the thickness, which is dx1 untuk plumber. Okay, going to copper, so kita ada negative K for copper, and then the area just label as A. Since the question said the area is the same, so T final minus T initial, and then we divide with dx2. Okay, so which quantity yang sama, then you can cancel. So negative we cancel, and then error we cancel. Okay, plug in the value for untuk thermal conductivity Kp plumber, so K sahaja. Okay, T final and T initial. So we know that the heat is transferred from higher temperature to low temperature. So the directions of the heat flow is to the right. Okay, so ini adalah directions of the heat flow. Jadi untuk plumber, since dia bergerak ke kanan, so dia akan bergerak from T1 to T2. So T2 would be the final temperature for the plumber. So dekat sini kita akan masukkan, so T2 minus dengan T1, which is the value is 70. So masukkan 70. And then the value for dx1 is 40. Make sure in SI unit. Okay, and then KCU, we declare it as 4 times thermal conductivity for plumber. So we write down as 4 kPb. So T final 4 copper pula. So it will the heat will flow from T2 to T3. So T3 would be the final temperature. So means you will minus T3 with T2. So T3U is 30. So T3 minus with T2. So kita tak tahu. T3 ni kita ganti dengan 30 lah. And then the thickness for copper is 60 times 10 power of negative 3. Okay, since thermal conductivity PB, left and right kita boleh cancel. Okay, sekarang doing your maths. Okay, kita buat cross multiplication. So, I akan dapat kat sini T2 minus 70 is equals to 30 minus T2. Dan yang ni I bawa pergi sebelah. I darab dengan I times dengan 4 and then bahagi dengan 60 times 10 power of negative 3. So, I dapat 2.667. Okay, so I expand. So, I dapat T2 minus 70 is equals to 80.01 minus 2.667 T2. And then rearrange your equations. Okay, so I dapat 3.667 T2. Okay, all of this is your maths. Okay, so you will end up your answer for T2 is 40.91 degrees Celsius. So that's the value for the junction temperature. Okay, that's all for this video and thank you very much.